Good afternoon. Welcome to FIPS Doesn't Have to Be a Four-Letter Word. Maybe I should have ended that with ... maybe, ? My name is Keith Walters. I'm from Northern Virginia. I'm a home brewer. I am a novice hair braider, not my own, my daughter's. I'm very proud of that. And you can find me online. I'm pretty accessible on Twitter, GitHub, and the ChefConf community Slack. But more pertinent to this discussion and why we're all here is I'm a software engineer. I've been a software engineer by trade for about 15 years or so. Working on helping users and developers, making the software development process just more pleasant, both in building pleasant systems and in having pleasant development experiences. For the past 7 years, I've been working for a company called Tapir Technology. Now, before I move on, I just have to clarify something, because I even heard this in the audience just a couple minutes ago. It's pronounced Tapir. I get this a lot. Like, what did you say? Tapir Technology, as in Tapir. Not to be confused with the Tapir, the animal. I didn't even know what this was until I started working at the company. And then people started asking me, oh, you mean like the animal? Like, what are you talking about? But over the years, this little guy's kind of grown on me and other people at the company, so we're kind of embracing it as our unofficial mascot. So if you want stickers, I have stickers. Come say hi to me. I'll be here all week. And I've got lots of fun stickers to give away. So you can get your Tapir, TAY-peer. All right. What do? We are a federal contractor founded in 2007. We're a small business. We have about 50 employees, and we're growing, currently with offices in Virginia, the Washington, D.C. area, Tampa, Florida, and Evergreen, Colorado. And some of our subject areas that we specialize in include software-defined radio, mission support, intelligence and analysis, and systems engineering, application development, and automation. And we support those subject areas for the DoD, the intelligence community, different areas of the federal government. And in addition to that, we are also a ChefConf certified partner. We've been working with ChefConf now we've been using ChefConf for 5 years. I think we've been partners for 4. We work with ChefConf to help them in the federal space and also help support their customers that are trying to benefit from ChefConf's solutions. So we work on site with different customers to enable their CI/CD pipelines, to provision their infrastructure, to automate their applications, and ensure their compliance using kind of the ChefConf suite of tools. This is actually the business unit that I am from. So if this is interesting to you, and I just want to let you know that we are hiring. So come say hi at the end of the conference or throughout the week. All right, so before we move on, as most of you are probably familiar, how many people are actually familiar with FIPS? Just show of hands. Wow, it's just about everyone. Awesome. This talk might not be for you because you probably have more experience with it. So as working with the federal government, I do not speak on behalf of the federal government. This talk is my own musings and observations and experiences, so I don't speak for the government. I also am not your security officer. Right, so the things that we talk about today with FIPS are related to security and how we secure systems and ensure that the right algorithms are being used. So don't take everything that I say as like de facto. Like, these are just ideas and things that I've had that have helped my team. Definitely take these things with you, and if they're valuable, talk to your own security officer about them. And I'm just not an expert in cryptology. I'm just going to throw that out there. Cryptology is important. FIPS is related to cryptology, but don't ask me exactly how certain things work, because I just don't know. So you all chose the most exciting talk of the week. We're here to talk about Federal Information Processing Standards, which is as exciting as it sounds, also known as FIPS. All right, so FIPS it's a set of publications that define standards for information systems in the federal government. Right? As technology starts to evolve and the information age, and agencies and contractors are working to build information systems, standards need to be defined. And in this particular case, we have standards defined by the US government for use in the US government, specifically by the National Institute of Standards and Technology, or NIST. There's a couple hundred of these publications dating all the way back to the 60s. And they cover a whole bunch of subject areas that we'll talk about, not in too much detail. But they exist to define standards where probably none existed before as technology kind of evolved over the years, or to take existing standards and extend them to meet the specific requirements of the government, depending on the security needs or interoperability requirements that systems might have to do. And the use of FIPS, it varies based off of your mission or your agency requirements, but there are a few things that are pretty much universal, and we'll kind of talk about one of them in particular today. So what kind of standards are we talking about? As kind of an easy pill to swallow, I picked a couple of simple ones. So country codes, right? When you're building an information system, you're gathering data, and you have systems talking to other systems, it's probably important that they use the same kind of codes to represent ideas or concepts, right? So in this case, the United States is designated as US according to FIPS publication 10-4. And the state of Washington, where we are this week for ChefConf, is US 53. Why is it 53? I'm not sure. I'm pretty sure there's only 50 states, but I'm sure there's a good reason for it. And calendar dates, right? Calendar dates can be confusing if everyone chooses their own format for representing what a date looks like. So FIPS standard 4-2 says, well, we should really use, YYY, 4-digit year, 2-digit month, 2-digit day, separated by dashes. And when everyone does that and you look at information, it makes sense, and systems can interop together because they're using the same types of standards. So standards come and go. Well, they don't necessarily go, but they might shift a little bit, or maybe they're managed by other organizations. There's the International Standards Organization and the American National Standards Institute, ANSI. There's several different governing bodies that work with and document and publish standards. And as those standards become more widely adopted by other communities outside of NIST, there is less precedent for those standards to be managed by the federal government because they adhere to the same requirements, and it's just easier if they're managed by another volunteer organization that wants to take that on. So over the years, several standards have, I said that there's been a couple hundred over the years of the past 50 years, and there's I think 9 left that are still active. These particular standards are replaced by, I mentioned the International Standards Organization, or ISO, country codes if you wanted to see the current country's code standards, which has been used to withdraw the FIPS 10-4 publication is 3166, and the date standard, which was also, I think, defined by ANSI, is also captured in ISO 8160. There are other standards in FIPS that range from how you read magnetic tape to how you write code in COBOL. Most of those are withdrawn because technology evolves over time and things change, right? So the standards that we kind of support today, or that NIST still manages, are more focused on the things that are most pertinent to our information systems, and that's security. All right, so there are, I think, 9 publications that are out there that cover encryption algorithms and identification processes and HMAC. If you want to learn more about any of these, I'm not going to go into detail on all of this, but you feel free to go to NIST's website. All of these documents are publicly available. So today we're just going to really talk about one FIPS standard, and it's the one that probably impacts most of us as we're building information systems, and that's FIPS 140-2. This standard is called the Security Requirements for Cryptographic Modules. And it's a really wordy way of saying the data that you use that you need to protect, encrypt, or digest should adhere to or be encrypted using algorithms that are approved for use by the federal government, right? We want to make sure that you're not using tainted or invalidated algorithms that have known to be vulnerable or that are detriments to the security of the things that we're trying to protect. So there's a specific set of algorithms, and you actually may recognize a few of them, AES, RSA, HMAC. There's certain things that we have to make sure that we do adhere to, and those are validated by the government. So this publication was created back in 2001, May of 2001, which you may be saying, that was a long time ago. How is this current? Which is a fair question. The specification, the version 2 of the 140 publication came out in 2001, but it's supplemented by several annexes, which cover subject matters relating from security functions that are approved, to approved random number generators, to approved key establishment techniques. And those documents are more regularly updated, even though they're not reflected by that date. I think when I was looking at them the other day, I saw that one of them was updated as recent as 2018. So as technology evolves, as vulnerabilities are discovered and things that are known to not be appropriate for our requirements, these annexes are regularly updated to make sure that the things that we do validate and the things that we do work with are secure. And they're done through a validation program, or the Cryptographic Module Validation Program, which is a government accreditation program that you as a vendor could apply for, bring your software or hardware device and get it tested by a cryptographic and security testing laboratory that's certified or accredited by the government. And they'll test it and they'll make sure that the things you're using are applying the appropriate algorithms, are encrypting data and treating it appropriately. And then they'll give you a certificate, and then you are certified to be FIPS, you're FIPS validated. So who does this apply to? Well, I kind of mentioned this before, but this basically applies to the United States government, specifically the employees and the contractors for the systems that we build and the systems that we use, right? So really inside of that overarching group of people, we're talking about, and from this perspective, we're talking about developers, security teams, your operations team. We need to make sure that when we're building information systems that we are adhering to those standards. Now, of course, your management probably cares, because making sure that we implement those standards means that that's going to impact our timetable and our ability to deliver. And auditors, of course, are going to want to make sure that we are adhering to those standards in addition to our security team. Users may care, maybe not. It might be more of a black box for them. But I mean, if they're using a government system that's got authority to operate in production, then they're using a system that has FIPS enabled on it. There is another group of people that should probably care about this, and that's vendors. So if you are a vendor and you're delivering software or hardware devices and you want the government to use it and be paid to have that be used by government customers, then you definitely need to make sure that you're aware of what FIPS is and you go through that validation program to kind of get your foot in the door. So there are, because the validation program exists, there are a whole ton of validated products that are continuously tested and certified to be FIPS compliant, ranging from the tools that we use every day: Linux, Windows, cloud providers, platforms like VMware, databases. You can go online. There's a website where you actually search for all of the validated modules that exist and see what's available and if the tools that you're using or you're considering to be used have gone through this program or not. Now, I would be remiss at ChefConf to not talk about one vendor in particular. That would be Chef. So the Chef suite of tools, now, while they have not gone through the validation program that I'm aware of, they do operate in a mode that is FIPS compatible, which means that they leverage other technologies to ensure that when they do things that leverage algorithms, that they are using only the approved algorithms through FIPS. So in terms of the Chef suite of tools, Chef Infra and Chef Client, Chef Infra Server, Chef Infra Supermarket now, as of December, Rob, yeah? All operate in FIPS mode. So if those are tools that you want to run in production, they're ready for you to use. Chef Automate supports FIPS. And Chef Automate's interesting because Chef Automate, especially Automate v2, is packaged and managed by Habitat. So Automate under the covers uses a build of openssl that has FIPS enabled inside of it to support its microservices. So all of those capabilities are running in a FIPS compatible mode, so that they should only be using the proper algorithms. And because that, so Chef Habitat is also can be run in environments where the applications, it's kind of up to the developers at this point to make sure you're using the right libraries when you're building your own dependencies. But if you do that properly, you can use Habitat to manage your applications in FIPS mode if you set up those plans properly. And Chef InSpec doesn't really need FIPS mode too much. I think like the big thing with InSpec is it just rides on SSH to talk to boxes. We use InSpec to scan all of our FIPS-enabled systems, and we haven't run into any issues. So as far as I know, I'm going to say Chef InSpec is compatible, but if anyone disagrees with me, I'd love to hear your story after the end of the talk. Yeah. So why? So tying this back to kind of a real-world example, or a real story with a trivial example. How I came to learn about some of this was some work that I was doing in Ruby, or particularly something that my team was doing in a cookbook, where we needed to build a custom resource that had to interact with a third-party API. And some data we had to provide to that API was a SHA, right? So we had to generate a SHA based off of some content. So we were in Ruby. We're like, oh, okay, no big deal. We're just going to import the digest module from the Ruby standard library, and we're just going to use the hex digest method, give it the content, and it spews out the SHA that we need. And the API was happy. And we developed it, and it was fine. The unit test worked out great. Now, in the kind of the waterfall delivery model that we had at the time with this particular customer, you would churn on development for a period of time, and things would move into test eventually, or more of a formal test. And then once those tests passed or the testers were satisfied, then your code would go into some kind of a deployment mode, and that deployment mode that deployed environment would then become hardened or secured and scanned by security, and make sure that your STIGs or your security technical implementation guides passed, FIPS was enforced, and maybe any other scanning tools that your security team at the time was using to just ensure that you were meeting all the minimum requirements were good. And then if all of that goes well, then you get authority to operate, and things can move off to the next environment, maybe production. But in our particular case, that didn't happen. So this little nugget of code, when we got all the way through to the security side and tried to run it with all the hardening enabled, we got this error. Forbidden in FIPS mode. What the FIPS does that mean? I had never seen that before up until that point in time. So this was new to me. So because of this, we failed the FIPS test, which means in kind of the waterfall mode that we had at the time, we had to go all the way back to the beginning, try to reproduce the bug, create a mitigation for it, fix it, run it through testing again, then run it through deployment, and then get back to security and say, okay, please try again, and hope that we didn't discover anything else. So all of that can take a lot of time, right, if you're in that delivery model. So how could we make it better, right? The reason we were in that situation is because our development environment didn't match our hardened environment. Because we didn't have access to the tools, both platform tools and security tools, to help us reproduce that environment, nor did we think that we needed them at the time. And we also clearly, naively had a limited exposure to our true security requirements as developers. So this was something that we had to learn and overcome. And this is where DevSecOps kind of comes in, the buzzword that everybody loves, right? And it's a good thing because it brings developers, security, and operations together. And when you do that, everyone that's involved in the project or the effort can create a common understanding of what the requirements are. So the things that I didn't know about before, I now have a greater appreciation for because security is bringing things to my attention in a way that I didn't have before. Maybe in the past it was a giant PDF and I didn't know what to do with the PDF. But and through that you can create a process where everyone kind of collaborates together and work in a way that as developers make changes, we can work with operations security to ensure that the changes we make are appropriate for the environments that we're going to be deploying into. And those security teams and operations teams provided us with the tools that we needed to be able to test and reproduce these issues earlier in our pipeline, right? And when you do that, your problems can be identified that you may not have known about before much earlier, and they can be fixed on a shorter interval because now I can remediate a bug and I can get security operations involved to help me verify my results in a way that I might not have comprehended before. And when those things are all in sync, it can help you get to ATO a little bit easier as if everything's passing hardening on a more regular basis. So when you in order to identify these problems early, the thing that we did was we baked FIPS into our image templates, right? And that put FIPS into our pipeline much earlier in the development process. And using tools like Test Kitchen, we're able to verify that our code, our cookbooks, and even our common off-the-shelf software, COTS products, were able to operate in an environment that more closely matched to the areas that we were about to deploy to. And we could validate all of this behavior with InSpec. So in order to bake FIPS into your image templates, you have to turn on what's called FIPS mode, is what it's usually referred to. And FIPS mode is just a way for an application or a platform to kind of prevent like hardware or software from using the unapproved algorithms, right? So if we know what FIPS is, we know that these are the approved algorithms based off of the standard and annexes, then that's what we can enforce. And we can enforce that in a couple of different positions, right? So we can either enforce it directly in the application or service that we're trying to run or build. And we could either do that internally by making sure that our application does all of its work itself and we've fully implemented an encryption algorithm to spec, which might be a lot of work. Or we could leverage other libraries or frameworks to help us with that are already FIPS compatible, like the openssl library. And you can also enable this directly on the platform, such as in Windows or Linux, right? So you can put it right on your kernel set when your operating system boots up. Your kernel is running in a mode that is enforcing FIPS requirements. So if you've got applications or systems that are trying to interact with system calls that might be doing something that they shouldn't or running an unapproved algorithm, the kernel will shut that down. So going back to our trivial Ruby example, enabling FIPS mode is something that you can do right in Ruby, assuming that your build of Ruby is built against a FIPS-compatible version of openssl. And by requiring the openssl library, the openssl module has a FIPS mode method. You can just set that to true. And when we do that, we're able to reproduce the error that we saw in the hardened environment. So now we're able to take the results that we saw that caused us to fail and reproduce that in our development environment and create tests to make sure that this doesn't happen again. And then to fix that, the openssl module in Ruby, or the standard library, is FIPS compliant. So if you just use the openssl module and with the hex digest method, then you'll get the same result, or the correct result using the approved algorithms. Now, this is specific to Ruby. Obviously, other languages and frameworks have their own solution to this. You know, Java has the Java cryptography extension. I believe IBM's is FIPS approved. I'm not sure if Oracle is off the top of my head. I'd like to think that it is. So depending on the tools and technologies that you use, you know, your solution may differ depending on what you're trying to do. In our particular case, because this was in a cookbook, we actually didn't need to set that FIPS mode ourselves because the Chef client and Chef infra is able to do that for us. If you're running Chef client by hand on the command line, all you have to do is give it the --FIPS flag, and it will enable that FIPS mode for you because Chef client is built using that FIPS-compatible version of openssl. And if you're bootstrapping new nodes, you can provide the FIPS flag to knife bootstrap, and that'll put the configuration into Chef client to say, hey, when this Chef client runs, just run it with FIPS mode enabled. Or if your modes are already bootstrapped, you could just edit the Chef configuration file yourself and set the FIPS flag to true, or use a cookbook to manage that if you want to. Now, the other side of it, so that was solving the problem at the application layer. The other place where you can enable FIPS is at the operating system. And in RedHat Linux, the procedures for this are just you have to install a package called dracut, which basically creates a new init ramfs boot file that has it enables the integrity verification modules that the kernel's going to need to properly boot in a secure mode so it can make these types of enforcements. And then once you have that new boot image created from this command, then you just add the FIPS =1 flag to your command line Linux configuration, your bootloader, in this case grub, and rebuild your grub configuration. And when you reboot the box, the system will come up with FIPS mode enabled on it. Now, for more information about these particular instructions, you can Google this and find the instructions on Red Hat, but they're also on the slides here that'll be posted, I think, online after the conference sometime. And in Windows, I think the steps are a little easier. At least in an unmanaged Windows, if you open your group policy editor and look for the Windows settings and open up your security options under local policies, the particular setting is going to be the system cryptography, use FIPS compliant algorithms for encryption, hashing and signing. And you just toggle that from disabled to enabled. And with this, actually, there's no restart requirement on this. Once it's turned on, it's on. Now, this is, again, we're at ChefConf, so I don't think we want to do that manually on all of our systems. So you could automate it, and there's a cookbook for that. FIPSify supports Linux and Windows. And once you've enabled FIPS in your infrastructure, you can also scan for it with Chef InSpec. So in this case, I've got two controls. One verifies that FIPS itself is enabled in the running kernel operating system. This is for Linux, by the way. And then the other control verifies that the bootloader is configured to enable FIPS if the machine is rebooted for any reason. So for both of these, for the runtime enablement, there's a device file that you can read, and it should have the value 1 in it. Or there's a kernel parameter called crypto.fips_enabled, and its value should also be 1. And then for the booting, this basically just compares the work that was done in the enablement to ensure that regular expression matches the FIPS equals 1, or looks for the FIPS equals 1 pattern in your bootloader configuration. So that way there's confidence that if the system's ever rebooted, then FIPS will continue to be supported on the box. And if you run that on your fake host like I did, all the tests should come back green. Yeah, so once you have enabled FIPS in your image templates and integrated that into your pipeline, now you're able to identify FIPS violations much more earlier in the process. And one other area where you can benefit from that is watching your software updates. As you're bringing in software updates and patches to applications and systems that you work on, you have more confidence earlier in the process that these changes will be verified. So by testing early with FIPS before you roll things out, you have more confidence that things are going to work the way you expect them to, and you won't hopefully have any remediations when security comes to scan your systems. Another tip that I found to be handy is to keep a non-FIPS image of your operating systems around. Sometimes you may be working with a COTS product that doesn't support FIPS, but it is critical to the solution that you're building or the project that you're working on, or you're prototyping a product and it meets all of your requirements. In those situations, which I've been in, there's no harm in calling your vendor and talking to them about it. So, and I've had really good success with that, both with Chef and with other vendors, where we've worked with products that we've had to improve FIPS support. And while we were waiting on those types of changes, we were also able to work with security to say, we have, in order to keep our approval to proceed, these things are in flight, and can we get a waiver to continue the rest of our efforts before we have to go to production? And our security team was pretty amenable to that, but it's a conversation that's always worth having. Never take that option of talking to security off the table. So in summary, I guess the whole point of this was just really emphasize the importance of integrating FIPS and security earlier into your dev and testing process. By testing your code and your software and your COTS early and often with your security requirements enabled, you're able to kind of avoid potential incompatibilities or eliminate risks of having your entire project paused because you're violating some serious concerns that you shouldn't be violating. In addition to that, work with your vendors to add FIPS support when you need it, and work with your security team to better understand not just your FIPS requirements, but your security requirements in general, whether that be STIGs or other requirements that they may have. Compliance is always continuous, right? So when you're working on your development process and you have approval to proceed, you don't have to have FIPS. You don't have to have all of your security requirements right away. I mean, obviously you need to have them before you get your authority to operate, but that journey to ATO is a process where you're going to continue to make improvements and to fix your, to mitigate your findings. So take the time to understand the findings and work them into your process and include them in your planning. And if you aren't in the government or you're not required to use FIPS, don't. But use your best judgment in turning it on if you feel like it's something that there's benefit in for your use case. I've got a bunch of references. Again, when this is published, hopefully these links will be more accessible, but you can find information online about the existing publications for FIPS. You can see the FIPS 142 standard. FIPS 140-3 is actually published and released in March and approved by the Secretary of Commerce, so that's coming out. I think it'll be active. I mean, it's out now. You can read it, but it should be active in September of 2019. And I think the validation program will start enforcing it maybe in 2020. And then there's more resources on FIPS itself and openssl and the module validation program. And if you're curious about how ChefConf Infra handles FIPS under the covers, there's a little snippet of code, line 1175 of the ChefConf config.rb files. It's how they deal with some incompatible FIPS Ruby libraries. That's all I have. Are there any questions or any stories people want to share? We got time. This is also the last session of the day, so. Yeah.
I don't have any stories, but I was wondering, have you run into a situation where a vendor would not work with you to kind of enable FIPS? And if so, what have you done to kind of remediate that?
I think that happened once, and we said goodbye. Yeah. But I mean, everyone's situation could be different, and if you work with your security team, maybe there's a good reason why that particular system, or you could put risks in, or you could mitigate risks or put some precautionary things in place to alleviate some concerns about that not being enabled if your security team is okay with that. Everything comes down to making sure your security team, you have all the right requirements from them and that they're okay with the risks that you're putting into place.
You said that the PowerPoint would be published. Where?
I should probably post this somewhere. I think that all the conferences will be online in YouTube. I don't know if they're going to be anywhere else, but yeah.
Okay.
Okay, thank you very much. If I've got stickers, and I'll just be around, so if you want to say hi and share your stories, I'd love to talk to you about your federal journey if you're on one.